are very interested in learning how to get their jobs working on our systems. And we also are looking for users to support in this adventure. So my talk today, I'm going to talk about how to get your jobs, GPU jobs, AI jobs on our systems at the OSPool. So I am a research computing facilitator. I talk mostly with researchers who are getting started, or maybe they've run into some sort of bug when they're submitting jobs. So this is my job here. To start off, there are a couple of stats from the last year in the OSPool. We have had about 600,000 total GPU hours run on the Open Science Pool, which is pretty good, but I think we can do better. When we look at this slice of the pie, you'll see that the top three GPU hour projects are in kind of the hard sciences. So we have the ubiquitous IceCube, and then we have two chemistry projects. But if we look in some of the projects in the middle of the pack, you'll see that we have a Wayne State University project, Chun Shen, doing nuclear physics. Also in the middle, you'll see that Eric Wright's project has about 157 GPU hours, so that's pretty cool. And our David Swanson awardee, she has put in over 3,000 GPU hours on the OSPool, and so she's ranked number 8 in our leaderboard. So this could be you, or this could be some of the researchers you support. And so we want more researchers doing more GPU jobs on the Open Science Pool. So how do you run GPU jobs? So let's take you under our wing. So say you are a researcher and your name is Ian Ross, and you want to train a model using images that you have scavenged from the social channel in Slack to classify whether pictures are cats or dogs. And so Ian, being a very smart researcher, has come to us before he's even started development. And he asks us these questions. What do I need to consider as I'm developing this model, as I'm running jobs in CHTC or the OSPool? And later on, how can he improve his training? So we like the way that he has framed this, because this follows our researcher-to-AI workflow proficiency pipeline. So first, we're going to develop and test the AI workflow or machine learning workflow that he is developing. Then we need to put it on one of our systems, so CHTC, the local pool, or in the Open Science Pool. And then lastly, thinking about how to improve this workflow once it starts running. So the first phase is to develop and test this workflow. And so the objective here is really just getting a minimally viable workflow running on a local machine first, just to test that it works. But you want to design it in a way that it lays a foundation for running a bunch of distributed work that will accomplish the full scale of science that you want to do. So some things that you should consider during development. First off, always test with a subset of your data. You don't want to run your full test on your local computer. That's probably not why you have an account on the OSPool. Especially if you're doing really, really large models, you want that small subset of data first. As you're developing, you also want to consider time, space, and GPU needs. Particularly on the OSPool, we are good at fitting certain types of jobs that are relatively short and a laptop size or slightly bigger than a laptop. So when you are developing your model, you want to think about what resources that you need. We also want you to reduce your computational project into this minimally viable workflow. And what I mean by that is, for example, if you're doing some sort of hyperparameter tuning and doing lots of different trainings, you might have a workflow that looks like this. But we want you to focus on just that big chunk in the middle, just one subset, and get that part working before we think about all the other pieces or extra fancy stuff that we want to stuff into our computational project. So the rest of that other stuff in your workflow, you can let HT Condor handle that sort of scaling. So we're just going to focus on one piece here. So I tell Ian this. He thinks about it. He goes and does his development, and he comes back with a training script for me. So I'm no expert here, but Ian is. So he tells me that he has defined different parts of his model, a dataset handler. Uh, Interestingly and very helpfully, he's added some command line arguments into his Python script to handle some of the data that is inputted and outputted. He has a little line that uses CUDA as the backend, defines some other things, and then trains and saves the model. So I look at this script as a non-expert and I'm like, okay, this looks good to me. Let's try to get it running. So we have all these steps here. And then the last step is to know your software and create the software environment. And this is sort of kind of a transition step between moving from your laptop to our high throughput computing systems. So in this step, obviously you need to know your software, what you're using. So Ian's using Python with a couple of packages. And he asked me, how can I put this on the Open Science Pool? How do I get my software working? Can you install it for me? And the answer is no, I'm not installing your software, but you can install it yourself with containers. And so containers, for a researcher, what you really need to know is that it's a self-contained operating system that can be executed on different computers, regardless of what their operating system is. So you can think of containers as a sort of backpack. So when you're going camping, you have your essential equipment. So you're always going to bring maybe a tent, a sleeping bag, a water bottle, a first aid kit. This is your core set of materials. So that's your container. Other things that you put in your backpack might be different depending on where you're going. So if you're camping in California, that set is going to be much different than when you are backpacking in Canada or Banff or something, right? So in the same way, we want to think of our container as a backpack where you have your operating system, the command line tools that you use, any programs that you need, or environment variables. Those are going to be your core set of materials or equipment, but things can change per job that you're running. So your input files may be different, or maybe your training script might be slightly different, right? So this is a good analogy for a container. So containers provide this sort of portability, which is very helpful on the Open Science Pool because you can run on a heterogeneous pool of machines. So, the Open Science Pool is very, very heterogeneous. You don't know what machine you're going to land on. So a container kind of contains that environment for you so you know it's going to be consistent. It also gives you control over what packages you want to add. So if you need a specific version of Python or a specific package in there, you can install that yourself. And it's relatively easy to build. So you just build the container once, and then you can deploy it. So as far as container engines go, we support Apptainer on the Open Science Pool. This is pretty great for new users. And you can build those images directly on our systems without having to download the software on your own laptop. And so we have a lot of guides on how to do that. I'm going to take a little segue into our local system, CHTC. We do support the Docker engine in our local pool. And this is great for users who are familiar with Docker and makes it easy to share images. So if you're a user on the Open Science Pool and you want to use a Docker image, have no fear, you can easily convert this into an Apptainer image. So I give this information to our researcher, and so he comes up with a Docker file that defines his environment for his jobs. So some things to point out here, we start with a standard CUDA image. So this is a really good one to start with if you don't know which one you want to use. Then we install Python 3.12 and pip, and then install the packages that we want later on. So it is fairly simple to define this recipe and run it. And so once we've done that, then we have our container image. So the next step is to then distribute this work to the high throughput system. So we've done our testing, we've made sure it works, we have our software environment. Now we want to actually run this job on the OSPool. So the objective here is to effectively utilize the available resources we have to train this model, or maybe variants of this model. So in terms of resources that we have, in the OSPool, we have a variety of GPUs. So you could land on a machine that has one of these GPUs, maybe a different one. Just don't ask how many GPUs we have. That's a very common question, and the answer is it depends. When are you looking at the OSPool? All you really need to do to access one of these GPUs is you add one line in your submit file, and that line is request GPUs. So just request a GPU. We have some optional submit file options. So GPU's minimum capability. So if you know what capability you need for your scripts, you can define that, and that will ensure that you land on a machine with that capability at least. You can also define the minimum memory that you need for that GPU. And so these are optional, and they will limit the options available to you. But if that's necessary for your scripts, that's available there. Sidestepping into our local pool at CHTC, what we've implemented is this policy of job links for GPUs. So here we have a policy of short, medium, and long jobs for GPUs. And we've limited the users to a certain capacity depending on the job length. And this is really to encourage the users to think about the length of their jobs and how they are using the GPUs. So you can see that with short jobs, you can use up to 2/3 of the available GPUs in the pool. So we're encouraging users to have jobs that are short. If they want to do long jobs, they can. That's up to 7 days, but you're really only limited to 4 GPUs maximum. And so by doing this, we're encouraging users to think about maximizing their workload capacity by submitting lots and lots of short jobs rather than hogging a single machine with a long job. So to opt in, we have some options here for the shared GPUs, and also we require them to define the GPU job length, otherwise it defaults to short, I believe. We also have researcher-owned GPUs in our local pool, and half of them, so half of the GPUs are owned by research groups, but users are able to backfill into them by adding this option, and with the understanding that those jobs can be kicked off at any time. So one more thing about putting your jobs on our system is about handling data. And for users new to Condor, this is a pretty difficult concept because they are used to a system where everything is shared, right? So we like to emphasize that, the files that you see here on the access point, those are in a totally separate file system from the execution point. So on home, that's where users store their small files. And then on the OSPool, you'll have another space that is OSPool/data, or on CHTC, this space is called staging, and that's where large files go, like your containers and your big data sets. And so HT Condor transfers those small files, no worries about that. The Pelican client transfers these large files, and users don't know the word Pelican, but they do know that they have to put in this interesting plugin in their transfer input files. So I tell Ian that he creates a submit file, and so it has lots of different things. He requests a GPU with some certain capabilities and minimum memory, and then he submits it. Yay, it works. So now that we have this on our system, the next state is we want to think about improving this workflow. So the objective here is to really get more out of the available resources we have, so doing more with less. and then monitoring and organizing these runs. So one useful tool we have is Dagman. If you haven't used it, I encourage you to try it. It's pretty cool. And you can really use it in things like these workflows where you have multiple steps that you need to do, or you want to coordinate all these jobs that you're running. And you can think big and think about, not being limited to just one training, but doing multiple trainings or working on multiple data sets. There's this tool called weights and biases. This works on our system as well as you expect, but just be aware there may be some API key leakage when you're using it. One other useful tool is checkpointing your jobs, and for training, this is perfect. And so this provides resilience against job eviction. So if you can checkpoint your jobs can restart at that checkpoint. So some required changes for that is you'll need a exit code that is printed out whenever you are checkpointing. So this exit code is usually 85. And you also need to define when to save that checkpoint, whether it's saving after every epoch or at a certain time. And so this needs to be done with your code that is executing, but also in your submit file, you'll need to specify that exit code and also the files that need to be saved. Some other gotchas and tips, you want to be aware of CUDA capability. Any number that corresponds to that computational capability, if you need it in your code, be aware of that. There's a really great table on Wikipedia that shows you that. Also, another thing is if you're using a Conda environment but not utilizing the GPU, you might need to specify the GPU-specific version of PyTorch TensorFlow. We have a number of really great guides, so please read those. Also, checking your job logs. That's the first place that we as facilitators check whenever you're asking, like, how can my jobs do better? So look at the memory, CPU, and disk that you're using, as well as the GPU memory. And please ask for help and give us feedback. That's something that we're always looking for, especially since we want more GPU users. We want you to tell us what's making it difficult for you to submit these jobs, and so that we can make those necessary changes. So with that, please stay connected with the facilitation team. So this is 6 of us. You've seen our faces over and over. We have office hours every week, usually, and training opportunities regularly. Please check out our guides page. I also want to shout out to Ian, who is our GPU expert. So sometimes when we don't know the answer, we also talk to him, and you might as well. So with that, that's all I have.
Thank you, Amber. We have time for a couple of questions.
Thanks, Amber. That was a talk. Is there a plan in the future to increase the number of GPUs that are available? Because you noted that our team had used 157 or so hours. We could easily use the whole 610,000 hours. So we had to basically change everything we were doing because the throughput just wasn't there.
Mm-hmm. Yeah, so with the number of GPUs, I do think, of course, we always want to add more. I don't know what the current plan is, but we are definitely looking for more GPUs, and we want to expand that for sure.
So I'll jump in on that. There's 2 ways to answer that. One from the UW-Madison campus point of view, and one from the OSPool point of view. The shared part of the answer is if you come and talk to us, especially if you know that I have a lot more in my pocket that I could be doing, I'm not, because I don't think there's availability. If we know that, then we have the ability to go get more. That's true both on the OSPool side and the Madison campus side. And then also for anybody from the Madison campus here, we also every year look at what's the balance of GPUs we should purchase, how much should we allocate here versus there. And part of the thing that we take into account is user feedback. So we love one of the things we do is we see what people have in queue and try to make a guess, but it's much harder to take a guess for things that just don't get put in the queue because things are too small by an order of magnitude. So we have tricks in our back pocket.
So following up on that, on the OSPool side, because that's my focus. Let's talk. But the more I understand about, kind of what you folks are looking for, I know there's sort of latent capacity waiting to be contributed to the OSPool. So the more that I know, the more that I can kind of shake the tree and see if we can start getting some of that contributed more regularly.
A quick question, probably a request. This was a great presentation of step by step. So you need to do this. Now, let's assume I was not fortunate to hear the presentation. Do we have anything that follows this line rather than here are all the options and now figure out what to do?
Yeah.
Can we turn what you have into, I don't know, to repeat it, or even just the presentation, or to record you? Because this is, for me, really powerful, but I feel we don't have anything like this available if I'm not listening to you.
So this exact cat dog example is available. We have a step-by-step kind of README guide that's right now it's sort of tucked away inside of our recipes.
Yeah, so it doesn't exist. Okay, it is not different than Todd's answer that yes, it is mentioned on page 700, the sub. So it's great, but how do we make it available to somebody who wakes up in the morning and wants to figure out whether it's a cat or a dog?
Yes, I will say we do have a GPU training that is recorded available on our website. But I do think having this kind of broad overview kind of like would be.
Yeah, no overviews. No, you presented it at the. No, you presented it as here's the problem. You have a bunch of cats and dog pictures, and you want to classify them, right?
Yes.
And the answer of talk to us. I'm continuously being criticized for that. This doesn't scale. But if this was on online, it can be a first step.
Yes.
I have one quick question.
Yes.
Maybe my mic is working. Also a nice test. On the CHTC GPU pool, I was kind of curious, in terms of user usage, which sort of queue do they use? The short, the medium, or long more?
Well, that's a good question because a lot of people will run short jobs, but then they exit immediately, and then because they're running something and it runs into error. So we see a lot of short jobs. But I would say in general, we do, because short is also the default.
I guess intentionally
Intentionally is difficult to tell, but I would say it does kind of follow that curve where we do have mostly short jobs, then a couple of medium jobs, and then we do have a couple of users that they want to run these big heavy workloads. So it does tend to lean towards the shorter jobs. Yeah.
Okay, let's thank Amber.